Okay, boys, this is a help for those people who might struggle with the prep otherwise. The idea is that we've got different functions here. Now, if you remember in class, I remember telling you that I'd like you to think of the functions as follows. The function f here, if it takes an input x, which is basically what this is meaning, this f brackets x, it doesn't mean f times x, it means the function f takes in a value of x, then it produces 2 times x and then adds 1 to the end. Okay, so that's what we mean by that. Okay, we do a similar thing to the function g. Well, g is the function which takes in an input of x and produces the square of its input, so x squared, and then subtracts 3. And h of x is the function such that it takes in an x and produces 4 times x and then subtracts 3 afterwards. Okay, so let's try and answer some of the question here. So it says find the following composite function. So A, it says find fg of x. Now fg of x is the same notation as f brackets g of x. Okay, now remember what we need to do is to work from the inside first outwards. So we're going to work the inside first. So in other words, we're going to replace the inside, which is g of x, this bit here. So instead of writing g of x, we're going to write what g of x is, which of course is x squared minus 3. So we're going to write x squared minus 3 here. Now remember, this is the function f, okay, the function f, taking in an input of x squared minus 3. That's what that means. Now the function f takes in an input of x and doubles it and adds 1. So it needs to, this is my input, we need to double the input. Let's double the input. And then we need to add 1. So we add 1. Okay, and we can multiply out these brackets if we want to. 2 times x squared is 2x squared. 2 times minus 3 is minus 6. And then add the 1 that's there, giving 2x squared minus 5. Okay, let's do a similar question. Part B is asking us for g f of x. Now that's the same as g brackets f of x. Okay. Again, let's work from inside to out. So we leave the outside alone. We're going to replace our f of x with this, which is 2x plus 1. Okay, so now g, the function g, is operating on the input 2x plus 1. So remember what our function g does. It takes in an input, squares that input, and then subtracts 3. So we need to square the input. And the input is 2x plus 1, so we need to square that and then subtract 3. Notice I'm squaring all of the input. Okay? Now if you wanted to, you can multiply this out. So remember to square out brackets and FOIL them out. You don't just square the first and square the second. Okay, so let's 2x times 2x is 4x squared. 2x times 1 is 2x. Another 2x there. And then the last 1 plus 1 is 1. And then we're minus 3, which is already there. So 4x squared, 2x and 2x is 4x, 1 minus 3 is minus 2. Okay, so we could write it like that if we want to. To be honest, you're absolutely fine leaving it at that stage, because it's not really an example of multiplying out brackets. It's can you do composite functions. Okay, so here is fine. Some of them, though, are quite obviously nice to simplify. So here we can see that it's not much work to simplify this, so we might as well do it. Okay. Let's try part C. This part C is asking us to do f of x. Okay, so that's the same as that. And we're going to replace our f of x, which is 2x plus 1 here, into here. So this is f of 2x plus 1. Now remember, our function doubles the input and adds 1. So we need to double. Now our input is now this. So we double our new input and we add 1. Now this is a case where we really should multiply this out. It's nice and straightforward. 2 times 2x is 4x. 2 times 1 is 2. And add the 1 that's at the end. And we get 4x plus 3. Okay. So if there isn't a lot of multiplying out, squares and cubes and things like that, like there is here, I'd recommend you did a simplification job on it. Okay, so D now. D is asking us to do h of g of x, which of course is the same as h bracket g bracket x. Close bracket, close bracket. And we're going to replace the inside. So we get our g of x, which is here, look. Okay, so there's our g of x. And we're going to replace that into here. Okay, so this is equal to h of, and what was g of x again? Well, g of x was x squared minus 3, so we write x squared minus 3 here. Remember what our h function does. Our h function, at the top here, it takes in x, multiplies that by 4, and then subtracts 3. So 4 times the input, minus 3. Right, so we need 4 times the input, which is x squared minus 3. And then, oops, I forgot to turn that off, sorry, equals 4 times the input minus 3. Let's just check that was right. Yes, 4 times the input minus 3. Again, we could simply multiply this out. The bracket isn't being squared, so it seems sensible. So we get 4x squared, we're multiplying that, minus 12, and then minus 3 there. So we get 4x squared minus 15. Again, it's a nice simple multiplication, no squares going on here, so it's easy to do. Okay, part E. Here we're asked to find f of x, f of x. So we're going to replace f in the middle, in the inside, with its definition, which is 2x plus 1 at the top there, which is doubling and add 1. So if this is our new input now, so we're going to double it there, and then we're going to add 1, because that's what our function does, double add 1. Okay, multiply this out. 2 times 2x is 4x. 2 times 1 is 2. Add the 1 at the end, and we get 4x plus 3. Okay, f, h of x. Sorry, not f. F, sorry, it's h of x, beg your pardon. H of x. So what is h of x? Well, h of x is 4x minus 3. So we leave our outside one there, and we replace the inside with 4x minus 3. Now remember what h of x does. It quadruples the input and then subtracts 3. So we're going to quadruple the new input, and then we're going to subtract 3. Okay, multiply out again. 4 4s are 16, so that's 16x here. Minus 3 times 4 is minus 12, and then the minus 3 at the end. And we get 16x minus 15. So that's the idea of composite functions. We basically apply the inner function first and apply the result of that with the outer function. Now there's a couple of other questions that you are asked to do in later questions, and that's things like, if you look at question 8, it says f of x is 5x minus 1, and g of x is 4 over x plus 3. And it says solve f of g of x equals 24. Solve f of g of x is 24. So the first thing that we need to do, of course, is to find this thing as f of g of x. So i.e., leave the outside alone, that's our f, and replace the inside, the g of x, with this, which is 4 over x plus 3. Now this one's slightly more difficult if you think about what g does. What does g, the function g does? It takes x as an input and produces 4 divided by the input, and then after that we add 3. Okay, so, oh, I beg your pardon, we're doing f of this. Now what does f do? Ignore the last thing that I just did there, sorry. The function f is here, takes x as an input and produces 5 times the input and then subtracts 1. Okay, so that's what we need to do there. So we're going to do 5 times the input, and our input is 4 over x, add 3. So that's 5 times the input, and then we're going to subtract 1. Now we need to multiply that out now. Well, 5 lots of 4 over x, of course, is 20 over x. Remember, 5 times 4 over x is the same as 5 over 1 times 4 over x. Multiply the numerators, 20, multiply the denominators, x. So that's that. And then 4 times 3 is 15, and then we subtract the one that's there. So this is 20 over x plus 14. But they're asking us to solve this is equal to 24, so let's do that. So imagine all of this is 24, so this is 24, so this is 24. So we end up having to solve this, so we don't need these equal signs here. Right, so how do we solve that? Well, if you go back to how we did that before, we've got a denominator, which is or a fraction, and we don't want any fractions in here, so what we usually do is to multiply both sides by the denominator to do that. So let's do that. So we multiply both sides by x, and a lot of people, remember, weren't multiplying all of both sides by x, so if we multiply this term by x, we get 20 over x times x. We must multiply this term by x, 14x, and we must multiply the right by x, 24x. This x divided by this x cancels out, so we're left with 20 plus 14x is 24x. And then we subtract 14x from both sides, so we get 20 equals 10x, and then divide both sides by 10. So x is 20 divided by 10, which is 2. So our final solution is x equals 2. That's what we mean by question 8. Now the other things that you need to know is finding an inverse. So I'll quickly remind you of how to find an inverse example. So how do you find the inverse? Let's have a look at, for example, question 9. So question 9 says, if f of x equals 6x minus 10, if f of x equals 6x minus 10, and g of x is 2x. It says find the a f to the minus 1 of x. Okay, so what do? We let y equals 6x minus 10 because that's f. Okay, up there. And we're trying to, so the first step we do, remember in your notes, we rearrange to get x equals. So we add 10 to both sides, and then divide both sides by 6. Okay, so that's getting x equals, and we can swap that around if we want to. Now, the second step in your notes was to change the x's for y's and the y's for x's. So this x becomes a y, and this y becomes an x. Because remember, the inverse is the reflection in the line y equals x. And the final step was to write our desired inverse function, to be the right-hand side of this, which is x plus 10 over 6. Now, another way of thinking about that is if we're trying to find the inverse of this, we can think, well, what do I do to my x to construct this function? Well, I multiply it by 6, and then I subtract 10. Remember when we did this construction method for solving? Well, to find the inverse, if I start with x and do the opposite and backwards like we did before, we add 10 to both sides. In this case, just add 10 to the x, and then we divide both sides. We divide by 6. Okay, we'll do that again. Constructing this 6x minus 10, start with the x, and we construct this. So we multiply by 6 first, that's that bit, then we subtract 10. So we do the opposite and in reverse. Start with our x, we do the opposite of minus 10, which is times 10. Which is add 10. And then we do the opposite of times 6, which is divide by 6. And this is our inverse now. If you prefer to do it that way, it's fine. They are essentially exactly the same.